Have you ever contemplated the universe's expansion and wondered if it ever slows down? It's a question that has puzzled scientists for decades. The accepted understanding is that the universe has been steadily expanding since that monumental event we know as the Big Bang, like an inflating balloon on an infinite scale. But what if we told you that this long-held belief is being challenged? Nestled in the desert landscape of Arizona, the Nicholas U. Mayall telescope at Kitt Peak National Observatory has been gazing into the vastness of space, gathering data that suggests a different story. At the heart of this telescope is the Dark Energy Spectroscopic Instrument, or DESI, a tool that has unveiled a preliminary three-dimensional map of the universe by observing a staggering 6 million galaxies and quasars. This map reaches as far back as 11 billion years into the past, providing an unprecedented look at the universe's history. The data gathered by DESI paints a fascinating picture, suggesting that dark energy, the mysterious force that makes up 70% of the universe, may be evolving over time. And this evolution could be causing the rate of the universe's expansion to slow down. What if this expansion is not as constant as we once thought? The DESI, observing 6 million galaxies and quasars, has given us a preliminary three-dimensional map of the universe, reaching up to 11 billion years into the past. This remarkable instrument, the Dark Energy Spectroscopic Instrument, or DESI, peers into the cosmic depths, providing a unique perspective on our universe's structure. Its findings have been nothing short of groundbreaking. The data suggests that dark energy, this elusive substance that comprises a staggering 70% of our universe, may not be as constant as we once believed. Indeed, this mysterious force, which we've long considered a fixed and unchanging entity, might be evolving over time. Evolution implies change, growth, and adaptation, concepts that we haven't traditionally associated with dark energy. Yet here we are, faced with the possibility that this dominant cosmic player might be far more dynamic than we've ever considered. And what might this mean for the universe? Well, if dark energy is changing, it could be influencing the rate at which our universe expands. DSI's results hint at a recent slowdown in the universe's expansion rate, which confronts our long-standing belief of a constant, ever-accelerating expansion. Now, this is not a definitive proclamation, but rather a tantalizing suggestion that our universe might be more complex and dynamic than we've ever imagined. It's an exciting prospect, one that challenges our understanding and forces us to question our assumptions. But science is never static. It evolves, just like the universe it seeks to understand. And with instruments like DESI, we will continue to probe, question, and discover, shedding light on these cosmic mysteries. These findings hint at a universe that is more dynamic and complex than we could ever imagine. These initial results are shaking the foundations of our cosmological models. Imagine the universe as a grand symphony, with each cosmological model acting as the sheet music guiding our understanding. These new findings from the Dark Energy Spectroscopic Instrument, or DESI, are akin to discovering an unexpected key change in the middle of the composition. The implications of these findings are profound. Dark energy, the elusive force that makes up about 70% of the universe, was believed to be a constant, unchanging aspect of the cosmos. But DESI's observations of 6 million galaxies and quasars up to 11 billion years in the past suggest that dark energy may be evolving over time. This could mean that the universe's expansion rate is slowing down, a concept that contradicts our current understanding of the cosmos. If these initial findings hold true, they could necessitate a complete overhaul of our current cosmological models. Just as a key change in a symphony requires the musicians to adapt their playing, we too will need to adjust our theories and models to account for this potential shift in the universe's behavior. However, it's important to note that this is just the beginning. These results are preliminary, and further research is needed to confirm these findings. The DESI instrument is still in its early stages of operation, and its continued observations will provide valuable data in the coming years. Despite the uncertainty, these findings open up a new realm of questions and possibilities in the field of cosmology. They remind us that the universe is a vast, complex entity that is always evolving, always changing. And just when we think we have it all figured out, it throws us a curveball, challenging us to adapt and evolve our understanding. As we continue to gaze into the cosmos, we are reminded that the universe holds secrets far beyond our current understanding, forever urging us to explore and discover.